All right, welcome. Today, we're basically going to build the entire universe. Well, okay, maybe not build it, but we're going to learn how to measure it, which in physics, that's pretty much the same thing. So let's dive right into the absolute foundation of it all, measurement.
But before we get into the nitty-gritty, let's just try a quick thought experiment. I want you to imagine a world where the unit we call a foot was literally measured using your foot, or my foot, or, your neighbor's foot. What would that world actually look like? Can you picture it?
Yeah, in one word, chaos. Absolute chaos. I mean, think about it. Building a house would be a total nightmare. Trying to buy shoes online? Impossible. And science? Well, science as we know it just wouldn't exist.
So that's our first section, a world without rules. And let's be clear, this isn't just a problem for scientists in a lab. This kind of chaos would be a massive problem for absolutely everyone.
So here's the real problem, right? Without a standard, a scientist in Tokyo could never, ever replicate an experiment from Toronto. It'd be impossible. Trade would be totally unfair. My kilogram of something could be way different than yours. And construction, oh, forget about it. Nothing would ever fit together. Basically, progress, it would just grind to a halt.
Okay, so how did we fix this mess? Well, humanity came up with this really elegant system to bring order out of all that chaos. And it all starts with quantities, units, and order, basically defining what we're even measuring in the first place.
So first up, we have this idea of a physical quantity. And look, this is really just a fancy name for anything we can actually measure. Length is a physical quantity. So is time. So is temperature. Basically, if you can put a number on it, congratulations, it's a physical quantity. Okay, so to measure all these quantities, we need some building blocks, and these are called base units. The best way to think about them, they're like the primary colors of measurement. They're the absolute fundamental starting points that everyone on the planet agrees on.
And, well, if base units are our primary colors, red, blue, yellow, then derived units are every other color you can possibly make by mixing them together. We're talking purple, green, orange. They're just combinations of the base units that let us describe much more complex stuff. And all of this comes together in the solution the world finally agreed on. It's a universal language for measurement, and it's called the SI system. That stands for the International System of Units. This system, this is what keeps that chaos at bay. All right, section 3, the 7 base ingredients. Let's actually look at these building blocks. Now, you might be thinking, to describe our whole incredibly complex universe, we'd need, hundreds of these base units, right? But the amazing part is how few we actually need. That's the number, 7. Just 7. With only 7 fundamental ingredients, we can describe and measure every single physical thing we know of. Think about that for a second. It's an unbelievably powerful idea. And here they are, the magnificent 7. You've got length, which we measure in meters. Mass in kilograms, time, of course, in seconds. Then we have electric current in amperes, temperature in Kelvin, the amount of substance in moles, and finally, luminous intensity, which is measured in candelas. That's it. These 7 are the bedrock, the absolute foundation of all measurement in physics. Okay, now for the really fun part. We're going to take our 7 ingredients and start cooking. This is section 4, creating with derived quantities, where we see how to build measurements for more complicated ideas. So let's build one. We'll start with a classic everyone knows, speed, right? We all kind of know what speed is, but how do you actually measure it using only those 7 base units we just talked about? It's actually super simple. You just take ingredient number 1, which is length, measured in meters, and you combine it with ingredient number 2, time, measured in seconds. And how do we combine them? We just divide the length by the time. And boom, that gives us our derived quantity, speed, with its very own derived unit, meters per second. See? We just built something totally new from those basic parts. And we can just keep on building from there. Want to measure volume? That's just length times length times length. So meters cubed. What about acceleration? That's just speed divided by time. And force, the famous one, that's mass times acceleration. Every single one of these is just a different recipe using our 7 base ingredients. Okay, so let's bring this all home. Section 5, your physics foundation. Why did we just spend all this time talking about meters and kilograms? Well, because if you're studying physics, especially for something like the IGCSE, this isn't just a topic, it's the topic. Honestly, this is the most important takeaway. It's a direct piece of advice. Revise this concept until you know it inside and out. Every single formula, every experiment, every problem you're ever going to solve in physics, it all rests on this foundation. If you can get this right, I promise you, everything else becomes so much easier.
And I'm not exaggerating here. It doesn't matter if you're calculating the energy of the tiniest particle or the orbit of the biggest galaxy. The whole process starts right here, with these units. It really is the language of the universe.
So, I'm going to leave you with a question to chew on. When you realize you can measure literally everything, from the brightness of a distant star to the force of a tiny collision using just these 7 simple ingredients, what's the most complex, most amazing thing you can think of that this system lets us understand? Just something to think about. Thanks so much for tuning in.